Hey, welcome back. Eric Taylor here. In this video, we're going to learn about climbs. The aim, to understand the aerodynamic forces in a climb. That's what we're trying to learn here. What are those forces? How do we climb? Those sort of questions. Like many other presentations I give, we're going to start with a video, and while we're watching the video, pay attention to where the glare shield meets the horizon. So that's my pitch attitude, and then what happens when I move the flaps from takeoff to the up position. So let's take a look now.
Positive 5. Bump out traffic timing 203, Delta Charlie upwind, runway 7, making left traffic, bump out. 300 feet, speed check, flaps up.
Okay, cool, welcome back. Now we're going to get straight into this. How do we climb? So we need excess thrust horsepower available over that required for straight and level flight. That's how we climb. We need a certain amount of power to maintain ourselves in level flight, and then anything we have available in our engine above that, or excess thrust horsepower, that's going to be our ability to climb. We can see that here graphically in this image. This is for multi-engine airplanes, but we'll see here. Power available one engine is this line, and then power required one engine is here. And so the difference between what we need, power required, and the power available is our ability to climb. Basic steps. So when we want to climb, some basic steps. We first would start with our pitch power table, and then when we're looking at this pitch power table, we see, oh, I want to climb at 85 knots, clean configuration, I'm above 1,000 feet, full power, plus 5 degree pitch attitude. So the pitch power table tells me if I set a pitch attitude of plus 5 degrees, full power, I should expect to get an 85 knot climb. Alright, so now the basic steps. First, we set a pitch attitude and power setting. That's the first thing we're going to do. So we're going to remember, alright, I want to climb at 85 knots, and I need to set a plus 5 degree pitch attitude and full power. So I'm going to do those two things. I'm going to smoothly apply power, pitch, then I'm going to check my performance instruments. So then I'm going to look over, am I climbing at 85? And then back to my pitch attitude and power setting. So we check our performance instruments, make adjustments, and then check our instruments again. So we'll set a pitch attitude plus 5, full power. I adjust trim now. There's going to be that transitionary period though between when we're at straight and level and then in the climb, when our speed's changing, we're changing from cruise to now climb speed. We need to allow this transition period. So we set our pitch attitude, power setting, all right, checking our performance instruments, and then adjusting trim as necessary. Now I'm going to see while I'm climbing, I'm not climbing at 85, I'm actually at 95. So I'm going to need to look out, increase my pitch just a little bit more. I'm already at full power, adjust my trim, check my performance instruments, and that's the process that we go through when we're going to set a climb. Secondary effects of pitch and power. All right, now that we increase pitch, the secondary effect of that is going to be a decrease in airspeed. And so we know if we don't do anything else, if I pitch up, well then I'm going to start climbing, primary effect, but the secondary effect is a reduction of airspeed. Increasing power, the secondary effect is a pitch change and a yawing motion. Those are two secondary effects. So I know if we're flying straight and level, I punch in a bunch of power, well then there's going to be a pitch up moment due to the thrust line effect, and then we're going to have some yawing motions. We're going to talk about those here in a minute. First one being when we add power in a turn or in a climb, these things are going to be affecting us. Torque effect, and this is a review. The influence of engine torque on aircraft movement and control, generally exhibited as a left turning tendency. And we can see that graphically here. The engine, from the pilot's view, it spins to the right. So engine torque is this direction, but the reaction that we experience in the plane is opposite, so to the left. In order to counteract this, we would need some right rudder. P factor, asymmetric propeller loading. We understand this is causing a yawing motion to the left at high angles of attack, opposite in a descent. So most people, when we're having this conversation about P factor, I've always heard people talk about it in a climb and how P factor, we have the descending blade on the, let me pop over here. We have the descending blade on the right-hand side producing more thrust than the ascending blade on the left-hand side, right here. But that is for a climb. When we're in a descent, those roles reverse and it's opposite. We don't experience it much in the propeller sizes of the trainers, but larger propellers like a Caravan, those types, will have the opposite effect in a descent. So we have P factor, that's going to cause a yawing motion to the left. We're going to need right rudder in a climb because of that. Gyroscopic precession. This is the tendency of a spinning object to move about its axis when disrupted by a force. And it's getting disrupted by a force when we're in that transition period of the climb that causes a gyroscopic precession we'll need to account for. All right, now we move into some definitions. You're going to hear about these a lot. You might be familiar with it already, but as a review, best angle of climb. So best angle is Vx, which is going to give you the greatest gain in altitude over a period, over a distance. Then we're going to have best rate of climb, which is Vy, going to give you the greatest gain in altitude for a period of time. All right, very important terminology. Service ceiling is where the rate of climb drops below 100 feet per minute in a single engine airplane. So we're at the service ceiling when we're climbing up and we can't maintain 100 feet a minute. That's our service ceiling. It's 50 feet single engine in a twin. Absolute ceiling is the height at which the rate of climb drops to zero. All right. Influence of flaps. So we can see here when we pop in some flaps, the chord line changes, because the chord line is from the leading edge to the trailing edge. So the chord line changes. We're developing more lift, more drag. Things are changing. And then, let's see here, used for short field takeoffs with obstacles. That's just going to help us produce more lift and fly at the speeds that we need in order to get the greatest gain in altitude for a distance. All right. A few other things I'm going to talk about in the video that we saw, and we're going to watch that same video again. We're talking about now we take off with flaps in the takeoff position. We get to 300 feet. That's a safe altitude for us to transition to flaps up. So first, we make sure that we have a good speed, okay? Speed checks, flaps up selected. Now, what's going to happen if we don't do anything in the airplane with the controls? We go from flaps in the takeoff to flaps landing. What's going to happen is the nose will lower, and then we're going to accelerate. Now, the nose is going to lower because we're changing the wing shape, the camber line, and then we're going to accelerate because we're going to have less drag affecting the airplane. So what I do in this video is speed check, flaps up selected, and then when those flaps are moving, what I'm actually doing is I'm going to apply aft pressure on the control stick so that way I can maintain my speed. I don't begin to accelerate and the nose doesn't lower so much. So let's take another look at this video and we'll pay attention to what's going on when the flaps go from takeoff to up position.
Positive 5. Bump out, traffic diamond 203, Delta Charlie, upwind, runway 7, making left traffic, bump out. 300 feet, speed check, flaps up.
Okay, great, welcome back. So not a big deal, it was a pretty smooth transition when I went from the flaps and the takeoff to the flaps up. I really focus on maintaining a good pitch attitude with my horizon, meaning the difference between the cowling and the horizon and so forth. So now let's finish up. We're going to talk about the private pilot ACS. Airman Certification Standards. What are they saying? Well, they're looking for us to transition to a climb, pitch attitude, and power setting on an assigned heading using proper instrument cross-check, interpretation, and coordinated flight control application. So they want us to transition to a climb, pitch attitude, and power setting, which is the basis of what I just taught you. We have a pitch attitude and a power setting. If I want to climb at 85 knots, that's going to be a pitch attitude of +5 and full power. And then we want to cross-check our instruments and then fly coordinated. I didn't emphasize it too much with you, but we talked about those left turning tendencies that are going to affect us in a climb: torque, p-factor, spiraling, slipstream, gyroscopic precession. Those things, when we're climbing, are going to want to cause us to be out of balance, and we're going to need right rudder in a climb to maintain a straight and balanced flight condition while we're climbing. What else do they say? They like us to level off at an assigned altitude and maintain our altitude within 200 feet, plus or minus 200 feet, heading 20 degrees, airspeed plus or minus 10 knots. Common errors. So in a climb, over controlling, this is probably going to happen when we are getting inside. We're transitioned inside on our instruments versus using our outside visual references. So when we do that, when we use an outside visual reference where we want the glare shield to meet the horizon or have a certain distance, doing that versus using the instruments inside will prevent over controlling. The other part of this is just a mental side where we just need to smooth it out. When we're transitioning from straight and level flight to a climb, we don't need to just pop it up like we're in the Blue Angels. What we're going to do is pretend like we have passengers drinking coffee in the back and we don't want to spill it. So we're going to just nice, smooth, clean transition to our climb attitude. Improper rudder use. Definitely the first part of this is going to be not using the right rudder when we're in the climb. Those forces are going to affect us different than straight and level flight. In a climb, we're going to need to add right rudder typically. Not using trim. So when we set our climb pitch attitude, our power setting, we're cross-referencing our information, then we're going to set trim. But we also remember that there's this transition period from, we're flying at 110 knots and we're going to climb at 85. Well, there's a transitionary period between when our airspeed's at 110 and then 85. So then we need to let that full transition period complete itself and then continue to adjust our trim after that. So we're not done adjusting trim until that full transition period's over. Not using outside visual references, we've already discussed it. Very important to set that, because using the outside visual references, you get to see changes in your pitch attitude much easier than looking at the small attitude indicator in the plane. So definitely super important to do that. That's it for this video. Thank you for your attention, and I'll see you on the next one. Hey, hope you receive value from watching this video. If you'd like to learn more from me, I invite you to take advantage of a free 14-day trial of Flight Lab's mastery programs. And inside, you're going to learn how to take control of your training, elevate your flying skill, and experience a new level of confidence in the cockpit. So, link for that's in the description below. Check it out, and I'll see you on the next video. See ya!